Hi everyone. Starting today, we'll be focusing on graphs of functions. So today we'll be looking at transformations of quadratic functions based on h and k. So here's today's FLT. Given a quadratic function, I will be able to identify the effects of h and k by describing, graphing, or defining the function. Even though we say graphing, it's going to be more like sketching versus exact graphing. So first off, let's just go over some stuff about quadratic functions. So here's just a bunch of examples of graphs of quadratic functions. Notice that they are all parabolas. And we always have to have a good base to start off with. So let's take a look at the parent function. So we have y equals x squared. That's the parent function of quadratics. Think of it as the most basic form of a quadratic function. And today we're going to add some parameters h and k to this parent function. So what's h and k? Is it that Sanrio cat character? No, obviously, since it's math. So h and k are parameters, so we'll write something like this. So y equals parentheses x minus h parentheses squared plus k. So this is still a quadratic function. Now we just have added parameters h and k. So again, h and k are parameters. So they're not exactly variables in the sense that parameters have set values, whereas variables are unknown amounts. So these parameters have set values, and since they're not associated with any variable, they're actually constants. So they're just numbers. Notice here that h is on the inside of the parentheses. So it's kind of like still stuck with x, whereas k is by itself on the outside. Today we're going to focus on how these two parameters, h and k, have an effect on the graph of quadratic functions. So let's first focus on the effects of k. What happens when we adjust k? So here I am on my favorite website, Desmos, favorite kind of. And notice I have my parent function, y equals x squared. And I also typed out y equals x squared plus k to see the effects of k. Notice here if I click on add slider, I can change the value of k. So let me first set it at 0 and let me adjust the speed. And now I want you guys to focus on what happens as k gets larger. So as k becomes more positive and as k becomes more negative. What happens to the parabola? Sit back, relax, and observe. Okay, so you probably noticed that k determines whether you go up or down. So k determines your vertical translation. Specifically, if k is positive, the function translates upwards. So notice how the parabola moved up as k became more positive. And if k is negative, the function translates downwards. So when k is negative, notice how the parabola moved down. So now that we know the effects of k, let's take a look at some examples. For our first example, it says to describe and sketch y equals x squared plus 3. So notice we have to do two things. We have to describe and sketch the function. So let's first describe the function. Notice that this is a quadratic function because the highest degree is 2. So it's going to be a parabola that translates in one direction or another. So we have to find out which direction based on the k value. So we have this plus 3 right here. So k equals positive 3. What does it mean when k is positive? Well, that means it's going to move upwards. So we have a parabola that translates 3 units upwards. So again, we described this function, a parabola that translates 3 units upwards. And next we have to provide a sketch of the graph. What does it mean to provide a sketch? In your past math classes, you probably had to make like a table of your XY values and plot them and make them look super accurate. But now you're just providing a sketch, so like a generic idea. So like here's like an exact image versus a sketch. It still gets the idea across, I think. So I'm going to start off by drawing out the axes. So kind of setting it up like this. And then I'm going to add in my parent function. So again, this is my parent function, basically the most basic quadratic function you can have. Notice here how the parent function has its vertex at the origin. And we're shifting this 3 units upwards. So 1, 2, 3. And so this example, the parabola would look something like this. So we translated the original parabola, the parent function, 3 units upwards. So we were able to provide both a description and a sketch. In the next example, I'm going to describe and sketch y equals x squared minus 4. I notice that it's a quadratic function, so it's going to be a parabola that translates either up or down. But which way? Let's focus on the effect of k. Notice here our k value is negative. Our k equals negative 4. So what does that mean about the parabola? Since k is negative, our parabola is going to translate 4 units down. Again, a negative k value means you're going down. We also want to provide a sketch, so I'm going to start off by drawing the axes. And I sketch the parent function, and I'm going to move the parabola 4 units down. So 1, 2, 3, 4, and sketch my new parabola, which has been translated 4 units downwards. On Edpuzzle, please describe y equals x squared plus 7. And although you can't sketch on Edpuzzle, try sketching it out on your notebook. What would this look like? Now let's look at the effects of h. So what does the parameter h do? So again, I'm on Desmos. So I have my parent function y equals x squared. And to see the effects of the parameter h, I set up a second function, y equals parentheses x minus h, close the parentheses and square it. So using the slider tool, let's take a look at the effects of h. So you probably noticed that h makes the parabola move side to side. So h determines your horizontal translation. If h is positive, the function translates to the right. And if h is negative, the function translates to the left. So make sure to jot this down and let's take a look at some examples. So here I'm asked to describe and sketch y equals x minus 2 quantity squared. Let me write out that form with parameter h to see if it's an exact match. So x minus h quantity squared. Notice that they're written exactly the same way, and h is replaced by 2. So in this case, h is positive 2. Since h is positive, the parabola is going to move to the right. So we have a parabola that translates 2 units to the right. Again, h tells you whether to go left or right. In this case, we went to the right. So we provided a description. Now we have to provide a sketch. So similar to earlier, I'm going to draw out the basic axes. And then the parent function. Right, so that's the parent function. And we're moving this 2 units to the right. So our parabola for this example would look like this. Again, it's a very generic sketch. For this next example, we are going to describe and sketch y equals x plus 3 quantity squared. When I write out like the x minus h quantity squared form, I notice that this example, it's not an exact match. I want an exact match, kind of like Cinderella's like glass slippers. So I'm going to rewrite it so that it's an exact match. So x plus 3 is actually the same thing as x minus negative 3. And then don't forget the quantity squared. Because remember how a double negative just turns into a positive. Now I have the x minus h quantity squared form. In this case, h is replaced by negative 3. So right here, I know that h equals negative 3. Since it's negative, the parabola is going to translate to the left. So I have a parabola translated 3 units to the left. Again, this is because h is negative 3 right here. Next, let's do our sketch. So I'm going to draw out the axes. And then my parent function's right here. Then we move 3 units to the left. So I'm shifting my parabola 3 units to the left, and here's my final sketch. On Edpuzzle, please describe y equals x plus 6 quantity squared. Remember, you want it to exactly match the form x minus h quantity squared. Now let's combine the two effects together. So we have y equals x minus h quantity squared plus k. And now we know what the parameters h and k do. So the parameter k, this determines whether you're going to go up or down. And then what does h do? So h is right here. This parameter determines whether you'll translate the parabola to the left or to the right. So now let's combine these two effects together. So let's describe and sketch y equals x minus 4 quantity squared plus 2. First off, I'm just going to write out the generic form. So y equals x minus h quantity squared plus k, and I'm going to match it up. So I know that k is replaced by positive 2, so k equals positive 2. And then h is replaced by 4, so I know that h equals positive 4. So let me write the description out. I have a parabola that translates, and then you ask yourself, what do these h and k values mean? So looking at k equals positive 2, I know that we're translating 2 units upwards, and the h value tells us we're translating 4 units to the right. So I have a parabola that translates 2 units up and 4 units to the right. And now let's sketch this out. So I'm basically doing 2 movements now, either going up and down and going left or right. So again, I'm moving the parabola 2 units up and then 4 units to the right. So we're moving the vertex of the parabola 2 units up and then 4 units to the right. So the vertex of this parabola is moving right here, and so this is our sketch. In our next example, we'll be describing and sketching y equals x plus 5 quantity squared minus 2. So what are the effects of h and k here? I write out the generic form right here, y equals x minus h quantity squared plus k, and I notice that it's not a complete match. So let's rewrite this function. Again, we're going to rewrite the function because it's not an exact match. So instead, we can have, so x minus negative 5 quantity squared plus negative 2. Now we have an exact match to the x minus h quantity squared plus k form. And so I notice that k is replaced by negative 2. So k equals negative 2. And then h is replaced by -5, so h equals -5. So we have a parabola that translates, and then so think, which way is the parabola shifting? Since k equals -2, we're translating 2 units down. And since h equals -5, we're translating 5 units to the left. So we're shifting the parent function 2 units down and 5 units to the left. So what would this sketch look like here? Remember to draw your axes. And then my parent function is right here. And from here, we go 2 units down, so -2, and 5 units to the left, -5. So we're moving that vertex of the original parabola down 2 units and then left 5 units. So this is my new vertex. And my parabola would look something like this. Again, I know it looks a little off, but it's just a generic sketch. On Edpuzzle, please describe y equals x plus 4 quantity squared plus 8. And now let's go the other way. So what if we're provided the description and now we have to define the function? Let's take a look at some of those examples. Alright, so write a function matching this description. A parabola that translates 5 units down and 8 units to the right. So we have to find a quadratic function matching this criteria. Since it's a parabola, I know that it will have this generic form, y equals x minus h quantity squared plus k. But what are h and k? Let's figure this part out. So we're provided some clues in the description. So for k, notice that we're going 5 units down. That means k equals -5. And then, what about our parameter h? Well, our description says 8 units to the right, so that means h equals +8, or just 8. So let's replace h and k with these actual values. I have y equals x minus 8 quantity squared minus 5. I replace my parameters h and k with the actual values to get my final answer. And you can check your work by graphing it on Desmos. Compared to the parent function, has this function been translated correctly? Yes, notice that it's been translated 5 units down and 8 units to the right. Let's do another example together. So write a function matching this description. A parabola that translates 6 units up and 3 units to the left. Again, because it's a parabola, we know what form this function will have. Y equals x minus h quantity squared plus k. So k is defined as going 6 units up. And so I know that k equals +6. And then what about h? So the description tells us 3 units to the left. So that means h equals -3. Let's replace h and k with these values. So I have y equals x minus -3 quantity squared plus 6. So again, I replaced the h and k values. Notice a double negative becomes a positive, so I'm going to rewrite this. Y equals x plus 3 quantity squared plus 6. And again, you can check on Desmos. Notice that this parabola was translated 6 units up and 3 units to the left. Yay! So this is your final example for today. Write a function matching this description. A parabola that translates 3 units up and 1 unit to the right. So as a review, a quadratic function can have parameters h and k. So have the form y equals x minus h quantity squared plus k. And so these parameters tell you about how the parent function translates. So how does the parent function move around? H determines your horizontal translation, and K determines your vertical translation. Great job today, and please submit your notes on Canvas.